Hello everyone, welcome back to my YouTube channel. So for this week, I'm going to explain to you how you should answer the class activity questions. So altogether we have 5 different questions, and let's start with the first one. Question number 1. A gas mixture containing oxygen and nitrogen has a total pressure of 600 mmHg. If the mixture is 80% nitrogen, what is the pressure of oxygen in atm? Okay, when you have this kind of question, the first thing you need to look at is the information given to you. So given to you is 80% nitrogen and the total pressure is 600 mmHg. So in saying that, we can know that 80% from the total pressure is the pressure of nitrogen. So we can say pressure of nitrogen is actually 0.8 total pressure. Right. So now what is the total pressure? Given to you is 600 mmHg. So you need to convert this to atm. So what we know that 1 mmHg is equivalent to 0.001316 atm. Right? So from there we know that it has 600 mmHg. So 600 times 0.001316, so you should get 0.7896 atm. So this is your total pressure. So going back to here, pressure of nitrogen is actually 0.8 times the total pressure, which is 0.7896. So you should get 0.63168 atm. Right. Looking back at the question, you were asked what is the pressure of oxygen. So the pressure of oxygen, you need to minus the total pressure with the pressure of nitrogen. So what you're going to do is 0.7896 minus 0.63168 should be equivalent to 0.1579 atm, which is the pressure of oxygen. So this is the answer for the first question. Let's move on to question number 2. Two containers A and B are joined by a tube of negligible volume. The container are filled with an ideal gas at pressure of 2.3 times 10 to the power of 5 Pascal. Calculate the total amount of gas in mole in the linked container. Given to you in the question is this diagram as well. So how are you going to tackle this question? So the first thing that you need to do, you need to be able to convert 2.3 times 10 to the power of 5 Pascal to atm. So you can actually use your calculator directly, or you can use manual calculation, which is 1 over 1.013 times 10 to the power of 5. You need to times the amount of pressure that you have, which is 2.3 times 10 to the power of 5. So you should get 2.2705 atm. Alright, so the next thing that you are going to do is to convert these volumes into liter. So 3.1 times 10 to the power of 3, you need to divide by 1000. so you shall get 3.1 liter. Same goes with this one. For container B, 4.6 times 10 to the power of 3 divided by 1000, so you shall get 4.6 liter. So again, we need to convert the temperature. So 17 degrees Celsius plus 273, so you should get 290 Kelvin. So same goes with this one. For container B, 30 plus 273, so you should get 303 Kelvin. So now all of the values has been converted to the unit that can be used. So now we can get the total amount of gas, which is in mole, for both container. So what we are going to do is that we need to find the number of mole for each container, and then we are going to do the summation of it. Alright, so from the calculation that we have done just now, the total pressure is 2.2705 atm, and the volume for container A is 3.1 liter, while the volume for container B is 4.6 liter. And then the temperature for container A is 290 Kelvin, and the temperature for container B is equivalent to 303 Kelvin. Alright, so from here, what we are going to do is we are going to find the total number of mole for each container. So the N total is equivalent to, remember we are going to use the ideal gas law, because with an ideal gas, right, so we are going to use PV equivalent to nRT. So from there we can have your N is actually equivalent to PV over RT. So since we are going to find the N total, so we are going to do PAVA over RTA plus PBVB over RTB. So now what we are going to do is just plug in all the values that we have. So your pressure A is, because all of the gas in A and B container have the same pressure, which is 2.2705 atm, so 2.2705. So the volume here is 3.1. The value of R is the constant value, the constant gas constant, which is 0.0821, and your T is 290 Kelvin. So plus, so the pressure is the same, 2.2705. The volume is 4.6. Gas constants are the same, 0.0821, and your temperature is 303. Therefore, you will get your N total should be equivalent to 0.7154 mole. So this is the final answer for the second question. Question number 3. How many grams of water shall be produced by the combustion of 58.2 liter of CH4 at STP? Assume that there are excess of oxygen throughout the reaction. The first thing that you need to do in order for you to answer this question is you need to be able to know how to write a balance equation for this reaction. So you have CH4, and it is a combustion reaction, so you need to have oxygen. Then in the combustion you shall produce water and also carbon dioxide. So now you need to balance out this equation. So here you only have 2 oxygen, but here 2 plus 1 is 3. So what you are going to do is you need to add 2 here so that you have 4. So 2 times 1, so 2 plus another 2 here, so it's going to be 4 oxygen. And let's check on the hydrogen. 2 times 2 is equivalent to 4, and your carbon, you only have one carbon over here and one carbon over here. So this is a balanced equation already. So from this equation, we can see that 1 mole of methane, CH4, will produce 2 mole of water. So from here, then only we can proceed on to know what is the mass of water that shall be produced when this much of methane is being used in the combustion. Right, so in order for us to know how much, the number of mole of water that shall be produced, so we need to know how much methane is being used in this particular reactions. Given to you in the question, we have 58.2 liter of methane is being used at STP. So from there, we can use the ideal gas law, PV equivalent to nRT. So because it's stated here it is at STP, so your pressure is 180 m, and the volume is given in the question, which is 58.2 liter, is equivalent to N, the thing that you want to calculate. R is a constant, is a gas constant 0.0821, and the T at STP, so your T is 273. So from there, we can get the value of N for your methane is actually 2.5967 mole of methane. Right. So from here, we can use this equation, because from here we say that 1 mole of methane will produce 2 mole of water. So at the moment you have more than 1 mole, which is 2.5967 mole of CH4. So how much water that you're going to produce is 2 times 2.5967. Therefore, you should be able to get 5.1934 mole of water. Alright, since the question asks you to calculate the mass in gram, right? So instead of just stopping the calculation at the number of moles, so you need to convert that into mass. So number of mole is equivalent to mass over RMM. So the number of mole is the one that we have calculated just now, which is 5.1934, is equivalent to mass over RMM. So the RMM that we are talking about is the RMM for water, which is H2O. So H2O, so means that you have 2 molecules of hydrogen. So 2 times hydrogen is 1.0079 plus oxygen, which is 15.9994. So you should be able to get your mass equivalent to 93.5601 gram. So this is the final answer for the third question. Question number 4. What is the pH of 0.2 molar of ammonia solution at equilibrium if the Kb value for ammonia is 1.8 times 10 to the power of -5? Right, the first thing that we need to do in order for us to answer this question is we need to be able to write a balance equation for the dissociation of ammonia. So we have ammonia, which is NH3. So because now it states here that it's ammonia solution, so plus H2O. So it shall produce NH4 plus OH minus. So from there, we need to move on to the ice diagram. And please remember that in ice diagram, the H2O is not going to play a role. So at first, the pH of ammonia is the one that we are going to calculate, and then given to you is the initial concentration of ammonia, which is 0.2. So initially there's no product is being formed, so in change everything in the reactant shall be negative X and in product will be positive X. So at equilibrium is 0.2 minus X, X and X. Right. So when you want to calculate your Kb, it is equivalent to X times X divided by 0.2 minus X. Right. So from here, given to you, the value of Kb is 1.8 times 10 to the power of negative 5 is equivalent to X squared divided by 0.2. So this is an approximation method. So we can say that your X squared is equivalent to 3.6 times 10 to the power of negative 6. So you're going to do a square root of this value and then you can get the value of X is equivalent to 1.8974 times 10 to the power of negative 3. Since we are using the approximation method, so we need to do the test. So test is equivalent to the value of X that you get, which is 1.8974 times 10 to the power of negative 3 divided by the initial concentration, which is 0.2 times 100. So from there, you should be able to get 0.9487. So this is less than 0.5. So the value of X here is a proof. So from there, we can actually find the pH. So this one is OH minus. So OH minus is equivalent to X, whereby your X is this one. Right, so just a recap. The value of X that we get just now, X is equivalent to 1.8974 times 10 to the power of negative 3. In saying that, we can say that concentration of OH minus is equivalent to 1.8974 times 10 to the power of negative 3. You were asked to calculate the pH, but you only have the OH, the concentration of OH minus. Therefore, what you can calculate first is the POH, which is equivalent to negative log OH minus. So the value of OH minus is the value of X, so 1.8974 times 10 to the power of negative 3. So you can get your POH is equivalent to 2.7218. Right, but this is not all, because you were asked to calculate the pH, not the POH. So pH plus POH is equivalent to 14. So pH is equivalent to 14 minus your POH. So 14 minus 2.7218. So you get your pH is equivalent to 11.2782. So if you want to check whether or not your answer is correct, so this is an ammonia solution and it is Kb, it's a base. So your pH must be always more than 7, because below 7 it is acid and above 7 is base. So this is correct. Alright guys, we are now at the final question for the class activity for this week. So the acid dissociation constant Ka of a weak acid is 2.56 times 10 to the power of negative 4. Determine the pH of 4.25 times 10 to the power of negative 3 molar of identical weak acid. So the first thing that you need to do, you need to know that this is a Ka, so it's an acid. So to be able to make an ice diagram, you need to write the balance equation. So because you don't know what acid is it, so you can just use Ha will produce H plus A minus. From here we can write our ice diagram, so ICE. So the initial concentration is 4.25 times 10 to the power of negative 3. So at first it is 0 and 0. So this one must be negative x, positive x, positive x. Therefore you will get 4.25 times 10 to the power of negative 3 minus x. So x and x. So your Ka should be equivalent to x times x divided by 4.25 times 10 to the power of negative 3 minus x. Right, given to you the value of Ka is such 2.56 times 10 to the power of negative 4. So now I'm going to plug in the value. 2.56 times 10 to the power of negative 4 is actually equivalent to x squared divided by 4.25 times 10 to the power of negative 3 minus x. So since we are going to use the approximation method, so we are just going to ignore the minus x. So we shall get your x is equivalent to square root of 1.088 times 10 to the power of negative 6. Therefore, your x is equivalent to 1.0431 times 10 to the power of negative 3. Right. So since we are using the approximation method, so we need to test it out. So the test is the value of x, which is 1.0431 times 10 to the power of negative 3 divided by the initial concentration, which is 4.25 times 10 to the power of negative 3 times 100. So from here we get 24.5435. So this is more than 5%, so it's not approved. What we are going to do now is we are going to do the succession method. So initially the value of x that we get is equivalent to 1.0431 times 10 to the power of negative 3. So therefore, since our test is more than 5%, so we need to do the successive method, which we are going to find the new value of x. So Ka is equivalent to x squared divided by 4.25 times 10 to the power of negative 3 minus x. So we are going to substitute this x with the first value of x that we get in the first calculation. So your Ka is equivalent to x squared divided by 4.25 times 10 to the power of negative 3 minus 1.0431 times 10 to the power of negative 3. So in other words, because you were given the value of your Ka, so 2.56 times 10 to the power of negative 4 is equivalent to x squared divided by 3.2069 times 10 to the power of negative 3. So because I've already minus the value of x, so you will get this value. So from there you will get your x squared is equivalent to 8.2096 times 10 to the power of negative 7. So you need to square root this value, so you get your x equivalent to 9.0607 times 10 to the power of negative 4. Right, let's check again what the question wants you to do. You were asked to determine the value, the pH value. So since this is an acid, so the value of x is equivalent to the concentration of H+. Therefore, your pH is equivalent to negative log H+. Hence, your pH is negative log 9.0607 times 10 to the power of negative 4. So your pH is equivalent to 3.0428. So this is the final answer for the 5th question for our class activity for this week. Alright guys, so this is the end of our discussion for this week. Thank you very much for watching this video. I hope this video will help you understand more on the various topics that we discussed this week. So take care, stay safe, and see you again next week. Goodbye.